All right, geometry students, we are on our last lesson of chapter 6. We got 6.7, and today we're going to be talking about how we're going to find what the arc length is, the length of an arc. So like this right here, we would have an arc. We're going to find out what that distance actually is. Okay, so far in chapter 6, we have measured the size of an arc in degrees. Okay, so that's what we've done so far. We've just figured out the degrees of an arc. Like arc AB, if we're looking at this, we have this central angle, it's 45 degrees, and we know that my central angle and my arc is the same exact size. So this would also be 45 degrees. Okay, so that's what we've done so far, measuring the arc in degrees. What we also want to do is find the actual length of this arc. Okay, so we found circumference, we found the length around the circle. Now we want to find what the length of an actual arc would be. So like finding the length in inches, feet, centimeters, whatever that distance is. Okay, so that's what we're up to on our last lesson for chapter 6. So our first step is we got to find what fraction is the degrees of each arc. All right, so here's our first circle. We got this circle here, circle T. We want to find AB is what fraction of that circle. Like how much of a fraction of this arc is it compared to the entire circle. All right, so first we're going to set up our initial fraction for this. So my central angle here is a right angle, 90 degrees. So that means this arc is 90 degrees. Okay, so to make that into a fraction, this arc, 90 degrees, is, out of the entire fraction, 360 degrees. Okay, so there's my initial fraction. 90 degrees for that arc out of the whole entire thing, 360. All right, we're just going to simplify that fraction down. 90 and 360 each has a 0 at the end, so we can automatically cancel those to simplify this fraction. So then that gives us 9 over 36. We can simplify that down some more. 9 and 36, I know we can divide both of those by 9. So that will simplify that fraction down to 1/4. Okay, so that's the fraction of that arc compared to the entire circle. This arc is 1/4 of the entire circle. All right, so that's simplified down all the way, so we're done with that first one. Okay, so we got 2 more that we're going to work out. The next one we got for problem B is we're going to find what fraction is arc CED of the entire circle. So just looking at this arc CED, we can see we have the diameter here. We know it's the diameter because we got 2 endpoints and it passes through the middle of the circle. The diameter is half the circle, so we automatically know that this arc right here is 180 degrees. All right, and we know it's half a circle, so we could actually say that this is 1/2, but if we wanted to actually work it out, just to show you the extra steps, we could take 180, which is the size of the arc, over the entire size of the circle, 360. All right, and we would simplify that down. We can get rid of those 2 zeros at the end, and we're left with 18 over 36, which we can divide both of those by 18 to get 1/2. All right, we already knew it was 1/2, but there's the extra math to prove that it is actually 1/2. All right, so we got 2 of them done so far. And our last one here, we got circle P. Okay, in this one, we're told that EF, so from here all the way down to here, is 140 degrees. So we want to find what fraction is that compared to the entire circle. So we have 140 over the entire circle, 360 degrees. Okay, we can simplify that down, get rid of those zeros at the end, and we're left with 14 over 36. All right, now I got to find a number that will go into both 14 and 36. The simplest one that I know of that would work, they're both even, so I can divide by 2. And that'll give me 7 over 18. All right, and that's as much as we can simplify that down because 7's a prime number, so we can't go down any further. Okay, so there's our fractions for each one of those circles. That is our first step. All right, so now we're going to flip screens and we will get to what our second step is going to be. Okay, so once we get our fractions, all right, here's our formula to find what the arc length is going to be. All right, we take the fraction that we got and we multiply that by the diameter, and then we multiply that by pi. Okay, so we're going to multiply by diameter, multiply by pi. So let's get our fractions down. Here is our 3 circles we worked with before. This one was 1/4 was the fraction we came up with. This one was 1/2. And then this one was 7 over 18. Okay, so that was after step 1. We got our fractions for each one. Now we're going to take that fraction and we're going to multiply it by the diameter. All right, so taking a look at this circle here, I have a radius of 12. So my diameter would be all the way to the end of the circle. Radius is halfway, so this is also going to be 12, which means my entire diameter is going to be 24. All right, so I'm going to take my fraction and I'm going to multiply it by the diameter. So my diameter is 24, so we're just going to make that 24 over 1. All right, making 24 into a fraction. All right, then to multiply fractions, we multiply straight across. 1 times 24, 4 times 1. Okay, just to show you the long ways on what this would be, 24 over 4, which is going to simplify down to just 6. Okay, so there was my first step. I took the fraction, multiplied by the diameter. Okay, next we're going to multiply that by pi. And we're going to have 2 different answers for this. We're going to have exact form and approximate form. Okay, so if I take the answer 6 that I got already and I multiply it by pi, to do exact form, it would just be 6 times pi like that. Okay, and that's all we would do. All right, 6 times pi meters because we're working with meters. All right, to do approximate form, we would go 6 times the number we use for pi, 3.14. All right, and if we do that, that's going to get us an actual number we can use, 18.84 meters. Okay, so that would be the actual distance of this arc right here. Arc AB would be 18.84 meters. Okay, so there's our step on how we find distance. Let's go ahead and work out the other ones that we got here. So this circle we came up with, the fraction is 1/2. We're going to do our first step, multiply our arc fraction by the diameter. The diameter for this one, we got 4 here and 4 here, so it's going to be 8. All right, so we'll multiply this by 8 over 1. You guys can probably figure out what that is already, but just to demonstrate what that would come out to, it would multiply out to 8 over 2, multiplying straight across, and that's going to simplify down to 4. All right, now we got our 2 forms to put it in. We're going to take that 4, multiply it by pi. Exact form would look like this. 4 times pi, and this is in inches, so we'd put down inches. And then if we want the actual number for it, the approximate form, 4 times 3.14. All right, we multiply that out and we get 12.56. And that's in inches. Okay, so there's our second one. So we got one last fraction, one last example to do, one last circle. We're going to find the actual length of EF. So we're going to take our arc fraction, multiply it by the diameter. I'm only given the radius for this circle. I'm told the radius is 36, so if I did the diameter, that would also be another 36. So my distance all the way across is going to be 72, 36 and 36 to give me 72. So we're going to multiply that fraction by 72 over 1 because that's my diameter. All right, and then that's going to give me, if you multiply those straight across, you're going to get 504 over 18. All right, so then we're going to divide that. We're going to divide 504 by 18. Sometimes you'll get a decimal number. This time it just comes out to a whole number. That's going to give me 28. Okay, so that's after we multiplied our arc fraction by the diameter. We get 28. Now we're just going to multiply that by pi to get my exact form and my approximate form. So my exact form is going to look like 28 times pi, and that's in feet. Okay, so there's my exact form answer. My approximate form, 28 times the number we use for pi. And if you multiply those out, it's going to get you 87.92 feet. Okay, there you guys go. There is your lesson for finding the actual length of that arc. So from E to F, that would come out to 87.92 feet. Okay, that would be the actual distance, the actual length of that arc. All right, there's you guys' lesson. You guys got a worksheet to work on after this, and I'll see you guys next time in class, and we'll be doing the review for Chapter 6 and getting ready for the test.